Okay, this is the third video in a series. Topic's called the Binomial Theorem, which is kind of a neat topic, which you could do in Algebra 2. We're doing it in pre-K. You could really do it in either. But it's kind of a handy thing before you get to calculus because it has a lot of uses. So in the first couple of videos, we kind of worked through what are called combination numbers. We looked at Pascal's triangle. And now we're on page 2 of this PDF, which I hope you've downloaded and I hope you're working through. So we're going to expand these binomials, and we're going to do it, I said the long way, but the long way is just using algebra, right? And just as an example, number 7, a plus b squared, what does it mean to square a number? It means to write it twice and multiply it out. But they're binomials, and you learned back in Algebra 1 that this is called foiling, right? First, outer, inner, last. The inner term is AB, and then the last term is B times B is B squared. And we get this A squared, and the middle doubles up. That's what's kind of important here. Plus B squared. And that, what did that take? About 30 seconds? Not that long. But the problem becomes when you raise the power to anything beyond 2, it starts becoming cumbersome. So if we look at number 8, what do we have? We got to do a plus b times a plus b times another a plus b. Well, I'm gonna shorten this up a little bit. It's really a plus b and a plus b. That's a plus b squared times another a plus b. And we did the beginning, didn't we? Didn't we just do that here, right? So I can actually take my answer to number 7 to start number 8, right? A plus b squared is just a squared plus 2ab plus b squared. And I need to multiply that by a plus b. And now you could see where we have trouble, because now it's not just foiling, you have 6 multiplications because you have a trinomial times a binomial, and then you got to collect all the like terms after that. And that's why this becomes so cumbersome. But let's work through it. One more example here, right? So we'll take everything over here times a. We'll distribute the a, and we'll get a to the third. We'll get 2a squared b, and we'll get an ab squared. And then we'll take everything by b, right? You could see all these like lines. It really gets messy real quick here. So b times a squared would be an a squared b. And I'm going to write it right underneath. I'm going to kind of stagger these. I think you're going to see why in a minute. B times 2ab is a 2ab squared. And then finally, b times b squared would be b to the third. And the middle terms add up again. You could see they're like terms. I'm going to call that a 1 there, right? So if I add this up, it's a cubed, 3a squared b, 3, because 1 and 2 gives 3, ab squared, and then b to the third, or b cubed. The important numbers here are the coefficients. I think that's what I want you to notice about this. It turns out those numbers, and I'll highlight the coefficients in number 7 as well, are those choose numbers, or those binomial numbers we talked about on the front of this worksheet and in prior videos. And on the side here, just because it's so important, I'm going to copy down Pascal's triangle again, and you'll see what I'm talking about. I think that's enough for now. You could see that this 1, 2, 1 comes right there, and this 1, 3, 3, 1 comes right there, right? So those are called binomial coefficients because they come up when you take binomials and you raise them to powers. So now that you see the pattern, we don't have to kind of do this the long way. What you have to do is fill out those binomial coefficients. And then you got to look at I'm going to take number 8 as an example. Look what happened to the a's. We got a to the third, a to the second, a to the first, and then a disappeared, or a to the 0. And then just to highlight a different color, look at the b's. In the first term, we didn't have a b, and then we had b to the first, b to the second, b to the third. So the a's, the powers on a's descended from 3 down to 0. And for the b's, they ascended. They went up from 0 to b to the third. That's the pattern. That's really what the binomial theorem is. Now, number 9 says, do a plus b squared with the shortcut. Well, first of all, how would I do it? I would first write out those binomial coefficients. I'd go to Pascal's triangle. It's squared. Look to the second number in. That's a 2. So for a plus b squared, it's really the third row down. I don't really count that first row. It's a third row down. I'd write out the numbers 1, 2, 1. I'd take the a, and I'm going to descend that, right? I'm going to start with a to the second, a to the first, a to the 0. I'll write out a to the 0, even though a to the 0 is just 1. And then I'm going to take my b's. I'll change up the color. I'll ascend that. I'll start b to the 0, b to the first, b to the second. We throw in pluses between these. And that's really the binomial theorem. Of course, 0 powers don't count, so I'm not that they don't count, they equal 1. So what are you going to get? You're going to get 1a squared plus 2ab plus b to the second. Okay? Now, it becomes a little bit more difficult when you just don't have a's and b's, or if you don't have x's and y's. Here we have a 2a and a minus b. How are we going to do it? Of course, if you did the long way, it'd take you a heck of a long time. We're going to go down to, if it's 4th power, we're going to go to the 5th row of Pascal's triangle. We're going to go right here. Copy down those coefficients. Give yourself a lot of room on scrap paper. I'm going to give myself the whole page, 1, 4, 6, 4, 1. And I'm going to take, I'll do this in red. I'm going to take 2a, and I'm going to descend it. I'm going to take 2a, the power is the 4th, and then 2a to the 3rd, and then 2a to the 2nd, and then 2a to the 1st, and then finally 2a to the 0, which cancels out. And what's the second term? It's b. You got to bring that minus with the b. So it's going to be minus b. So it's minus b to the 0 power, minus b to the 1st, minus b squared. You're seeing why I left kind of all this room, because you got to fill in all these variables. Minus b to the 3rd, and finally minus b to the 4th. And in between, I just throw a whole bunch of plus signs in there. I think you'll see this. A 4th degree binomial, it will give you 5 terms. A 5th degree will give you 6 terms. You always have one more term than what the power is. And now you just do, really just do algebra 1. Now you gotta be careful. This is 2 to the 4th. That's 16 a to the 4th, right? Here I got a minus. I got 2 cubed, that's 8. So I got 4 times 8 times a cubed b. And again, I brought that minus there. You got to watch it. That minus there I brought out front. In the 3rd term over, I have a plus. I got 6. I got 2 squared is 4. And then I got a to the 2nd. See that minus there again? I got another minus, but it's squared, so the minus goes away. And I have b squared. And next up, I'm going to have a minus, because that minus gets cubed. That gives me a minus. And what do I have? 4 times 2, that's 8. A, b to the 3rd. And finally on the caboose, I got a minus to the 4th. That becomes a plus b to the 4th. And just clean up whatever you have to. Some of these I guess I could have done in one step, but I didn't. 4 and 8, that's 32. A cubed b. 6 and 4 is 24a squared, b squared. And the last two terms are simple. Again, that seemed like a lot of work, but if you did that the long way and you try to do 2a minus b times 2a minus b times 2a minus b times 2a minus b, really would have become difficult. A couple things I do want you to notice. Although we started with 1, 4, 6, 4, 1, we started with those binomial coefficients, so you didn't end that way, primarily because of the 2 in every term. And the other thing you got to check for, look at the variables. You got a to the fourth, a to the third, a to the second, a to the first, and then a to the 0. And then again, they still descend, and then your b's are going uphill. B to the 0, b to the first, b squared, b cubed, b to the fourth. So again, it looks like a lot of work, but it's much better than the alternative, which would be to kind of keep foiling things out. Okay, we're going to, in the next video, we're going to look at just a couple more examples of how to get better at this. Again, if that was confusing, hit the pause, rewind it, look at it again, kind of work through the problems with me. These are very doable if you can kind of put your mind to it. Okay, thanks for watching.